Hi all. In this video, we are going to present a paper titled Visual Object Direction using deformable part models. So this paper aims about to solve sliding window directions problem where uh, image or object has to be detected in a particular position in an image in a particular scale. So usually here this paper utilize binary linear classifiers which computer scores beta dot phi x. Beta is a parameter, model parameter, and phi x is a feature vector, and through threshold value it detects whether it belongs to a particular classifier or not. Unfortunately, this phi of x is not rich enough to represent the image for if the images are subject to variation due to eliminations and other variations that we have described in the earlier part of the paper, like variability in intra-class viewpoint eliminations and other things. So this paper tries to address these problems by bringing uh, important representation of the particular part of the image called pictorial structure. So pictorial structure means that it defines that in every object that has to be detected consists of many parts. So that parts has to be arranged in a specified structural subject to a small deformations. So this pictorial structure, which has many parts, and each part brings certain informations into the picture, and this collective information gives you a nice representation for that particular image, which can be utilized in this minor linear classifier for the directions. So this is what core idea of this paper. But how come they are going to identify what are the parts for a particular object? So that is a little bit cumbersome for making a training data. So that's where this paper is about. Tries to identify those parts during a training time by making deformal part model configurations. So what this deformal part model configuration is about, this is what described in section 2. So it has a way, it divides a particular image into 8 cross 8 blocks or patches. So each patches they try to identify histogram of gradient features, which represent that particular patch of that image in order to detect the object. Then that patches been convolved with a filter, which is also a bit dimensional less than the feature map, so that it convolves with every part of that feature maps. And the final and moreover another thing is it says that, as mentioned earlier, it has a deformable part models. One is like a straight, like kind of a star model. One, the first filter is a root filter, which is a low resolution filter, which covers whole image. And other filters, like if we have an n parts, we assume to be have an n parts, we have n low resolution filters covering each part of the image. So these collective filters, and that image representations, which is like a particular position on the scale, makes to combine to give this equation 2, and which the first part is something like each patch is make a dot product with that particular representations with that filter, and the second one is called as a deformation cost, which is something like a difference in the position with respect to the center position, like a group, like a centroid positions. So this scores gives you a certain representations compared to taking the pixel data directly for that linear classifier. And moreover, in addition to that, we have a pyramid of scales, so it gives you additional more scores, something like this, which is somewhat it is represented very nicely in this slides from the same author. So they try to say that we are going to do a linear classifier. This already they did in 2005, which directly they use these features and to represent a sliding window classifier. But to go for a in upgraded versions, they try to make different patches and try to go along with the root filter, like which covers the whole image, and these part filters cover each part of the particular object, and those informations are combined together to form a feature representations which can be utilized for the linear classifiers. So that's what motivations about this ideas, which is like a pictorial representation. For example, for a face, and these are the different parts, and these parts have been connected with the central overall representation of plot, like a kind of a deformation cast act like kind of a spring-like structures. So this is what is idea about these collective features are represented through this these are particular patches. So this filters, and this one is represented this score is computed from the dot product of this W and H, and every patches these scores are collected, and this based on these scores we try to identify try to identify and solve these linear classifications problems. For this acts like a filters and also the deformation cost. So these are the learnable filters and the deformation parameters, and these are the features that can be represented through this through its particular positions and the particular scale and their deformation cost. These are the feature vectors. So once this is a pictorial representations, and we have this, and we have a feature map, and these are the individual, these are the root filter, and these are the individual response filters, and they are concatenated here and gives you the particular features which can be used right in the binary classifier. And that classifiers are trained setting these as convex functions and using a standard convex solver and making a this is the objective functions which has a hinge loss, and through this solving they try to identify the best parameters for an object directions. For each and every object direction they try to solve a binary classifiers. So this is all about this information about this paper. So the overall aim is try to extract the useful informations as a features through the pixel arrangement of the pixel data, so that they are invariant to eliminations and translations and rotations and other complications in the variations in the poses and other things. Hopefully we will see in next paper how this is connected to the convolutional neural network. Thank you.